chapter 10, two sample, two test, independent sample design.
Mm-hmm.
This is stats.
And what day is today?
Today is the 3rd, October 3rd.
Yeah, and October already chilly, right?
Yes.
Okay, so this is our class. Yeah, we already get into the cold weather. Cannot believe that. Okay, but no matter how cold outside, I believe inside is warm because our heart is warm. Right?
Yeah.
Yeah. Right? Okay, so independent T, two sample T test. Okay, actually this may be a good chance. Let me show you a little bit map. Okay, I keep talking about map, but I didn't have a chance to talk to you about map. Okay, let me turn off.
I forgot about this.
Okay. Now, when we are working on our statistics, I'm telling you turn right, I tell you turn left, I tell you go straight. But actually, quite often students don't know why. Okay, so let me tell you a map, so then you'll be in control when you start to do all this work. Okay, so when we have data, right? When we have data, you sometimes have what called nominal data, right? Like category, the name, right? And sometimes you have ordinal data, right? But so far the one we work, we call scale. And scale including what? Scale including what? Interval and ratio. Right? Interval and ratio. What's the difference between interval and ratio? Interval is interval and ratio the same thing. They have a number in between. You can do decimal. Right? You can do decimal. Right? 5.2 different from 5.3. Right? But then nominal data, you cannot do that, right? We cannot say we have 5.2 people, right? But the difference between these two ratios, you have 0, absolutely 0. By interval, you don't have absolute 0. That's different. But then in SPSS, they consider they are scale. Okay, so if your data is scale data, okay, and in your calculation, either you want to do comparison or you want to do relationship. Right? Either you want to do comparison or you want to do relationship. So if you want to do comparison, then also you need to ask, what do I know? So you can have one group or two groups or more than two groups. Right? Right. And then we say one group. So far we done two ways to compare one group. Which two ways? Remember, one's G, one's T, right? G test, and then T test, right? And then what do we say the difference between G and T? If we can know the standard deviation from population. So, right, we compare when G is your group, maybe we can say your group. I would say group 1, so actually it's your group. Compare with what? The mean. Right? compare with the mean score, we call the test value, right? We call the nationwide average, right? But then also for G, you know what? You know standard deviation there, right? And then for T, you also have a group. You also compare with mu, right? But you don't know the standard deviation for population. You know small s. That makes sense? But then for this one, we treat your research as just whole group. You didn't divide any two groups. You not compare with your between group. You only compare your whole group with the population. Your sample with population. Okay, so that's one group. That's why we do that. We do that. 2 chapters, right? G test, T test. We call one sample T, right? Okay, now when we do the 2 group, okay, so you know this one called one sample T. Let me put on here. One sample T. Okay, now when you do 2 groups, okay, now they can be group 1 versus group 2. So you have 2 groups. And you want to compare. But this group have nothing to do with each other. Like a male, female. Like before I have this class, and then half of students have a Dr. Hawaii's for statistics. So I can say, you know, Dr. Hawaii's class and my class. So that's 2 groups. That's G1 versus G2. Okay, so compare 2 groups. Nothing to do with each other. But we want to compare their mean score. And in this case, we don't even know anything about mean. We don't know anything about population. That's why we want to compare our sample ourselves. Okay, so in this one, we will run independent T. Okay, independent T. Independent T. Okay, now next, after for break, next week, we are going to talk about also 2 groups, but it's 2 group data. Okay, so you have a group, and then they have a pre, and then post. So when we say group, 2 groups in here is same people have 2 group data. But these 2 data are actually the same kind of data. You have same questionnaire, pre-test and post-test. Okay? So then you got this, and since they are themselves pre-post. So we are running what kind of T? Dependent T. Okay? Okay? Now, if you have more than 2 groups, then you cannot use t-test. Because statistics believe the more you test it, the more error you're going to get. So if you can test the whole thing, you should use that one. Okay, so if you have more than 2 groups, and you only know independent t-test, then how do? You have to compare these 2, these 2, these 2, these 2. Then so many testing, then you get more error. So that's why they have called ANOVA. Okay, so we were going to run 1 way ANOVA. Okay, and of course you can do 1 way, you can do 2 way, you can do 3 way, you can do 4 way. But anybody know what mean 1 way, what mean 2 way, what mean 3 way? Do you know what the 1 way even mean? That means they have 1 independent variable. Okay, so this means 1, I'm just going to say ID, that's independent variable, okay? So for example, you want to test the school level, difference in their GPA, then your school level is one variable, right? But they have 3 groups or 4 groups. Okay. Then actually your Dr. Victor always wants students to do 2 by 2, 3 by 2, 4 by 5, something like this. Okay. That's called two-way ANOVA. So that means you have how many independent variables? If 2 by 2, that's how many independent variables? 2.
2.
Okay, now when you say 2 by 2, it means 2 labels here, 2 labels here. But you have 2 independent variables. So for example, gender and school label. Okay, that's 2. And of course you can do 3. 3-way, 4-way, 5-way. Okay, so that's 2-way, 2 independent variables. Okay, so this is the comparison. Okay, and of course in the future if you learn more then you can, but all these only have one dependent variable. Okay, if you need to do 2 dependent variables, then you need to do MANOVA. Okay, now beyond our class. Okay, but this is the comparison. Okay, how about you say, I don't want to do comparison. I really want to do relationship. Okay, then let's come here, relationship. That means I have one group, then I have 2 data. Rather than pre-post, I have data 1 and data 2. For example, stress and depression. Okay, your hours of sleep and your energy in the class. So same student, we measure 2 scores, and you want to see relationship. Okay, so this one we are going to run Pearson correlation. Okay, Pearson correlation. Okay, so right now you have a G, T, T, T. So you have G score. Let me put G, T, 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 and then what's this called? F. This will be F. This will be R. Okay? Okay, so then how many chapters already? 1, 2, 3, 4, 5, 6 chapters, right? Right, and then we have a couple chapters about discrete data. So we already covered so many chapters so far. Okay, now the last 2 chapters, actually they talk about, how about if your data is nominal data? Right, all this is scale. All this you only can do, they are scale. Okay, because you can get your mean score. You can get standard deviation. That's why you can do comparison. And then this, you also need to have a scale. Okay, but if your data is nominal, let me put not N there, the red color. Okay, and you cannot say, well, just I don't know. If they are nominal, I cannot do anything. Who said that? Right? So if you are nominal data, depend on what you want to do. Okay, so you can also see I want to do 1 group. Or I want to do 2 or more groups. Okay, so 1 group, and they are nominal data. So of course you cannot do mean score. Instead you do percentage. Okay, so for example, right now we say how many people support wear mask? How many people support not wearing mask? Okay, so then we say, okay, 51% people support where math is important. Okay, 49% people support where math is not important. Okay, and this maybe can be like your research paper, you ask people yes, no, true, false. Okay, then with these 2%, which one actually is, which one get the better support? Is wear mask or not wear mask? Which one? Huh? You mean this one?
Yeah.
Well, looks like, but we don't know they are significant different. Okay, so in this case, we have to run something called CHI SQUARE. How do you call that? Chi-square. Okay, so this actually is X squared. Okay, so if this the one, if we only have one group, that means we treat everybody the same, just like this, and we want to see in our group how many people support this, how many people support this. Okay, so we are going to run this called chi-square. I'm just going to say this, for goodness of feet. Okay, chi-square for goodness of feet. Okay, now if I have more than one group, that means I want to know, even wear mask, I want to see is male and female have different opinion about wear mask. Okay, so this will be mask, no mask. Or you can even stand outside the shopping mall. No, shopping mall not everybody wears, so that won't count. In the park, how about that? And then you say, okay, how many male, how many female, how many male, they wear mask or not mask, okay? And you find the male is 48, 52, female is 57 and 43. Okay? Then you can calculate, see if gender have anything associated with their mask behavior. Okay? Then you can also have a 3 group, 4 group to do this kind of association. Then this one called chi-square for independence. Okay? This map is so fun. They show you everything for the reason. Otherwise, you just go each chapter and say, oh, really? How many more? Well, with this map, you know everything for the reason. Everything for the reason. They design, work so hard for those statisticians, work so hard because they want to make sure you cover. Of course, they will have a like Spearman correlation for the ordinal or something. We will not cover for this class. But anyway, this will be very good general concept, and this will take you to the right airport, get a right terminal, and go to the right gate, and then get to the right country. Okay? And so that is very important. Okay, that makes sense? I didn't get this map until in my PhD program. I've been swimming, have no direction for so many years until I get to my PhD, and then because we had to take the general exam. That's our first step for PhD program, and so we have teacher and we have a TA, and the TA worked very hard to show us this map. And then after that, I said, wow, why don't you tell me early? So that's why I won't tell you early, right? And you're still very, very, very young. Then If you already know this, then in the future when you learn more, then you will add more in your picture, but you already know this part. Okay, so we already done D, we already done one sample T, and we are going to talk about this. Right? And then next time we'll talk about dependent T. And then we're going to talk about ANOVA, we talk about correlation, and then the last 2 chapters for this book will be chi-square. So this will be whole trip.
And then we have our PhD.
Huh?
And then we have our PhD.
Yeah, and then you'll be your PhD.
Thank you.
Okay? And so this should be the best gift I give to you. Every time when you look at this, oh, I remember that lady. It's from Tiffany on Saturday morning. Oh, I remember. Okay. Chris, what do you think about this map?
I think it's helpful.
It's very helpful, right? Nobody tell you this before today? Yeah. I don't know why. Who is the people in the whole world? Watch my channel, this one. Say yes. Yeah, right. Okay, but I really like this map. And then the more I talk about, the more I find it. But actually, when I took this to my undergraduates, then they are, because they are not go through the whole statistical process, so they are, all right? But
Yeah, my undergrad statistics class, we just learned how to put things in a calculator.
right?
Period.
No big picture.
No big picture.
No big picture.
No small picture.
Yeah, I know. Even no small picture.
Yeah, calculator.
Just calculate. So I don't know if they even have this in their program for those when they graduate, before they graduate, right? Testing your teacher, maybe they don't. They know. I think we know. But I think today is the right moment, because if I tell you earlier, these words is stranger to you right now because you know a little bit of them. So then when I start to put a map, then you start to say, oh, okay. Okay, so it's okay. I'm going to erase. Anybody want to take picture? I'm going to erase.
And we have the video, right?
Yeah, we have video. Okay. Maybe I
think I
should.
wrote it all down pretty good.
Yeah, maybe I should put more closer so people can look at. Okay. For those of you watch video, this is our raw map of statistic. Yeah. Yeah, because it's far away, people say, what are you talking about? Okay, so it's time to go to our independent T. Because it's not too hard to calculate. Or even you forget, you can go back to the book. But if you remember this picture, and in the future, if you are the boss, or you are the supervisor, you are advisor, then you will use this to tell your staff, say, I want you to run this. And they ask you what, and you tell them, they will think, oh my gosh, my boss is so smart. Okay.
Moving on.
Okay. So now you go to, remember before we have iPhone, you always need to go to AAA, right? If you need to go to do the traveling, do you know that time? Maybe your parents have to go to AAA and then they tell you how do you drive from here. They give you a lot of map. Right? So now we finish visiting AAA. Now we are going to do drive. Okay, that's right. Okay, so independently. And you know the difference between independent T and then the one sample T. What's the difference? What's different? What's different? Yes?
One group and two groups.
Huh?
Either one group or two groups.
Either one group or two group. Yes, that's a very good answer. Okay, so here, this picture under this page, right? So one sample T, we use one sample, a sample mean to test hypothesis about a population mean. Okay, so actually when you write your hypothesis, you always need to use the mu. Remember last week I forgot, I put T, right? And then I finally realized I should put mu there. Okay, so you are testing your hypothesis against the population mean. Okay, now for the two sample t-test, you are testing about two groups, they're both from your sample. And you want to see if these two samples, are they similar or are they different? Or which one better than which one? Or which one less than which one? Okay, so that is two samples, and these two samples have to be unrelated to each other. They have nothing to do with each other. Okay, unrelated. Okay, and so we also call them within subject design. So if they have something to do with each other, then we will change the between to what? Within. Okay, you will change between to within. But this one, when we say between, that means they have nothing to do with each other. Okay, so of course, at least you are testing, they are already clear cut like gender, right? Otherwise, you may want to do random sampling, random assignment, right? Random assignment for people to be group 1 or group 2 or group 1 or group 2. Okay. You know, right now in our undergraduate class here, they random assign students. Half them come to the first class, half them come to the second class. You know, that's what they do right now. We do hybrid, right? And so that is nothing to do with each other, right? So then I can even compare what's their performance between two groups, right? And they have to be separate. Okay, so now, since we are calculate this independent T, we have to do not only standard error, we are calculate standard error of difference. So this is your new formula. And also, please be careful that SM1 and M2, in between they have a line. What's the line? Are they hyphen or they are subtract? Hyphen. Okay, be very, very careful. Because I have students, they calculate M1 and they subtract M2. I said, no. They said, yeah, looks like M1 subtract M2. Mean 1 subtract mean 2. No, that is standard error of difference. And that between the line is hyphen, not subtracting. Okay? And then you can see the formula inside, even the formula looks new, but the information won't be that new because you will see, you have to calculate SS1 anyway. Okay, what's SS? What's the word mean? Yeah, sum of square. So you have to calculate sum of square 1 plus sum of square 2, okay, divide by the group 1 number plus group 2 and subtract 2. Okay, and then parenthesis, and here will be 1 divided by group 1 plus 1 divided by group 2. Okay, so that's the formula. So don't just use standard error. You need to use standard error of difference. Standard error of difference. Okay, and then this is just the formula for standard error. The sum of square. I just put here just in case you forgot. Okay, good? Mm-hmm. So see, that's your new friend. That's a new friend for your formula group. Your formula group, they are waiting for more new friends, right? Okay, now, how do you calculate the independent t? Okay, sorry, I tried to make my formula, that's just not working. They don't understand some of my parts, so then I said, okay, let me just take pictures. And it looks like it's not so clear, but then you can see, t of 10 is m1 subtract m2, still the same, not still the same, different. Before is m subtract mu, right? This one is group 1 subtract group 2, okay? Divide by standard error of difference. Okay? Now subtracting is standard error of difference. Okay, now another thing is degree of freedom. Okay, so degree of freedom, why subtract 2? Why? Why? Huh? Yeah, because you're 2n. You're 2 groups, each group loses 1 freedom. Right? So that is degree freedom. Okay? So now this actually from the book. Okay, so they talk about a political science teacher wonder whether there is difference in knowledge of current event between students who are read newspaper and or watch TV. Okay, and then of course this book is a little bit out of date now. Right now they maybe have to say either watch TV or use internet, right? So, but doesn't matter. So they have 2 groups there, and then group 1 they tell them only read newspaper. Okay, group 2 say you only watch TV, and then they are testing their knowledge. Okay, so this is the data. This is the data. Newspaper, TV news there. Okay, so our first hypothesis. Okay, and this is what? 2 tail. Okay, so right now, did you see that? It say mu1 equal mu2. Okay, or mu1 unequal mu2. Make sure you have that formula correct. Okay, mean. Why we still use mu? You say we don't know population, but why we still testing mean? Yeah, because no matter what we do, we are trying to predict the population. Okay, so if we say male different from female, and we assume if our result is, if we hypothesis, we testing, we say male different from female, we want to assume, so in the population, male is different from female for this issue. Okay, so that's why you always use male. Okay, now the second, and then of course, if you are greater or less, that's another story we talk about when we get to your turn. Okay, and we still use the same table. Okay, we still use this table. Do you still love this friend? Right, we still use this table. Okay, so let's see. So step 2, you have alpha level 0.05, right? And then you degree freedom. Because there is different number, 11, they have 10, so 11 plus 10 minus 2, so you got 19. Okay, so you're 19, 2 tail, 0.05, 2 tail, 0.05, 0.05, and 19, so we got the positive negative 2.093. So I believe up to this point everybody pretty good. Only thing, please don't ignore to write your hypothesis. Okay, that's the point there you want that. You want get every point you want that. Okay, and just by typing, you can just type and then next time you can just copy paste. Okay, so now we have to start to do our calculate. This also the part. Be very, 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 very careful. Okay, so then in your formula, you already know you need this number square. You need this number square. Because that's what we need for our formula. Right? So then I have those square. Because the number is so big, so then I'm not expecting you calculate here. Okay, let's just write look at the number, as long as you know it's come from square. Square, 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 square. Okay? And here, square, 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 square. Okay, and after you square, then you have to do is add them together, add them together, add them together, and add them together. Okay? And after you add them together, then you also need to divide. Get your mean score, and please don't make wrong calculation error. Some students, they can start to make error here. They start to, get number wrong. And I feel so sorry because after if you are wrong here, then everything here will be wrong. Okay, so make sure, double check, double check, double check. Okay, you know how to get mean score, right? Total divided by the number. Okay, so you got your mean one, and then you got this one, you got mean two, and you got this. Okay, so then I put there, we got SS1. Okay, again, if the number get to so big, chances are you are wrong. Okay, because you have a square already here, then this will be your smaller number square. Okay, and I found my former student, they put the sum of square here, and they put square, square. Then the number becomes so huge. So your number becomes so strange, then maybe you should recheck your answer. Okay? Then you got your second sum of square, right? Then you put them inside, and then you got this number, and then you got this number. Okay. Okay, now this one is divide. Okay, because I take pictures, so I have no way to put the formula here. So I need to type this one. Okay, so then, but it's M1 subtract M2 divided by sum of square of sum standard error of difference. Okay, so I get this number. Okay. And this number should be correct because from the book. So it should be right. Okay, so now you remember this number compared with the what number? Compare with the number. Right? Right? So your T of 10 compared with T critical, right?
Yep.
Okay. So which number bigger? T of 10 bigger. So are they fall into the rejection area or non-rejection area? Right? And this part, is different as PSS and the obtain and the driving and flying. We use different number to look at the significant amount, right? But actually they are for the same meaning. Okay, so we have a 2.1. What's our number? Okay, here. Okay, 0.93 positive and negative 2.093. And now in our calculation, we got 2.72. And if they are positive, they have no way to go there. So I should not write in that. Because they are not positive, negative. Okay, again, I think all of you may already know. If you calculate, if they are positive, don't put negative. Okay, if they are negative, then don't put positive. That's why we have two sides. Okay, so if positive, you go this side. Negative, they go that side. And they are in here, so they are falling into rejection area. Right? And then So our P, P is this part, the one I mark red. So P is what? Compared with 0.05. It's less or greater? Less. Right? Originally, you want to eat this big pizza, but your mother said you are so good, so you only eat small pizza. Okay, so your pizza gets smaller. That means you are in rejection area. And that in our statistics, that's good news. Okay, so that is very important. Decision. I don't find any trouble this in your homework for making decision wrong. I think pretty much good. I pretty believe everybody made the right decision. So that means you have a very good idea. Okay. Okay. So then, since we reject, so we have to calculate Cohen's effect size. Okay. And then this time they have this. Okay, that's kind of first part of your standard error of difference. Okay, so make sure you use this number. So that's SS1 plus SS2 divided by N1 plus N2 minus 2. You got 1.18. So then they give you large effect. So easy, right?
Yeah.
Right, so easy. Especially now you know the math. So it gives you a even better idea. Okay. Now let's go to one question from your turn. Okay. So now this one still do non-directional test. Okay. So then they want to do two group. Okay. To see if you put the music, it's helpful for the productivity for their staff, for their employee. So that one group you put the smooth jazz during the workday, and another one is they put nothing. Okay, and then you want to see with the alpha level 0.05 to see if music group and non-music group, are they different in their productivity? Okay, so here they say non-directional. So if non-directional, it means one way or two way. No, what's it about? One tail or two tail? Two tail. Okay. Okay, and the number is much, much smaller. That's easy to handle. Okay, is anybody a chance to work on this work? No, okay, so then let's work together. Okay, so you have sample 1 and sample B. That's the data. Okay, so how do you do hypothesis? Before I show it, somebody tell me. Yeah, mu1 equal mu2. Right? Yeah, the research hypothesis will be mu1 and equal mu2. Very good. Okay. And please, when you do your homework, don't do any calculation yet. Okay? When you see the number, try your hypothesis step 1 and do step 2 before you get to calculation. Okay? Okay, so then your alpha level 0.05. So what's your degree freedom? What's your degree freedom?
6
Oh,
and 5.
I cover and it's already there. What? What did you get?
For sample A, it's 6, and for sample B, it's 5.
No. All right. Sample A 7?
For degree of freedom,
No,
it'd be 11.
11. No, degree of freedom only one number. Oh, you want to say, okay, that's another
Oh,
way.
okay.
She subtract and plus, It's fine. So then 11, right? 11? Okay. 11 and it's 2. So 11 is here. Okay, and then 0.05. So the answer should be what? 2.201, right? Right? Jason? Okay. Is it good? Okay. Okay. And then make sure you write positive, negative. Because it's no direction. Okay? Two tail. Okay? So then you got this. So that's the first thing, make sure you are correct. Okay, so if we put here, then this term should be .201 positive, negative 2.201. Okay. Okay. Then we put in here, so let's calculate. Okay, so we got square. Okay, so 64, 181, 49, 64, 121, 144. And this will be 49, 36, 64, 100, 49, 81. Okay, then when you after calculate, then you need to put all this number. Okay, sum of x1. I got 65. Then you have 7 people. Okay, so you got your mean score is 9.29. Let's just take 2 decimal here. Okay, take 2 decimal. Okay, so then 47. Then you got a sum of x1 squared 623. You got a sum of x is 47, 6 people. So when you divide 7.83, the sum of square x squared 379. And then make sure before you move on, double check see if your answer is correct. Okay, so then let's calculate SS first. Okay, so I got a 19 there. I got 11 here. And also, the way if I see your work, you may have a decimal there, then that's why your answer will be different from me. Okay? So if you see your work, your answer may be somehow a little bit different from other people because it depends on how many decimal you take it. Okay. So then I just put the whole number because that's easier when you go to those calculations. Okay, so you have a sum of the standard error of the difference. And I got a number. And I got this number. And then if you want this formula, I think you can just copy paste to your Word document. Okay, and then your T of 10, you got 1.59. Okay, so 1.59, where? Here, 1.59. Okay, so just look at this. Are we reject or fail to reject? It's good news or bad news? Huh? Yeah, we fail to reject. Okay, so that's why for this one, I don't even calculate the Cohen D effect size because we already failed to reject here. So it's very important for making the right decision. Okay, especially when we are talking about research, if you are making wrong decision, not just a number wrong, you change the whole world. That's why I'm a little bit picky when I see you make wrong decision. Okay? Okay. And okay. So now step 4, we will say, make decision, report result. Then you say listening the smooth jazz music does not affect. Why is not the affect? Because it's fail to reject. So fail to reject HO, that means mu1 equal mu2. Either you put music or not in your company, doesn't matter. Their productivity is the same. Okay, so then fail to reject HO, again, make sure you write fail to reject HO, not just say fail to reject. Okay, and then P greater than 0.05. Okay, so far so good, right? This is the second brother of T, second T brother, right? Okay, so next one actually is about the direction. Okay, so this one is directional. Okay, so they want to do, to see if you give people enough sleep versus you don't give them sleep, and they affect their reaction time. Okay, so then we have 14, one group, 11, two groups. So what's the degree of freedom, this one? How do you get degree of freedom?
Add them and subtract 2.
Yeah, so 14 plus 11 subtract 2, so 23, right? Okay, and then also be clear, what do you mean beta? Okay, so this is the number. And the good news is you don't need to calculate that much. They already give you SS1 and SS2. They give you mean 1, mean 2. They give you N1, N2. Okay? And then alpha level is 0.05. Okay? Then you determine if sleep deprivation had a determined effect on reaction time. Okay? Now, they say higher score indicate worse performance. So before we move, I show you the hypothesis. So how do we set hypothesis? We put greater or put less? We say higher score indicate worse performance. You put greater in your research hypothesis. You put 2 groups, right? Okay, so mu1, mu2, HO and H1, mu1 and mu2. So which group didn't sleep? Group mu1, right? So then this should be worse, right? So worse will be what? Greater. Okay, so you assume you want to test in, see if mu1 have a, let's spend more time for reaction, right? Greater. So if this greater, then who take care of this part? What this should be? Less and equal. Make sure that somebody take care of the equal, okay? Otherwise, where's the equal go? Okay, so if this is the case, it's your T critical should be positive or negative?
Negative.
Hmm?
Negative.
It's greater or?
I don't know. I have a 50-50 shot of being right.
If they are greater, that means they should go here, go there. Hmm? Okay. Okay, so I put greater there, right? And it's here. Because you want them to be more time, you want them to spend more time for reaction. So 2, don't sleep is not good at all. Is anybody you didn't sleep yesterday night? Really?
Yeah, you guys drive me crazy.
For the whole night?
Like maybe like a couple hours.
I don't think it's me. You already finished my homework, right?
I was working on
Anybody
that.
else
I
didn't
still had to
sleep?
fix it.
Only in her, so then if we have something we say no, then she will be spending a lot of time trying to get everything. That'll be positive number. Positive does not mean good or bad. It just means in this research, we want to see are they really perform worse. And perform worse, that means they spend more time. Okay? Is that clear? If this is less, if this is less, then our T critical will be negative. Okay, so that's important. Okay? So then we got the number because from our chart. Okay? So 1.714. Let me put the number here. And this is one direction. So if you draw the chart for me, then I only expect to see one side. And that'll be 1.714. Okay, and the calculation the same. Okay, just because that one L, that's no different. Okay, only different is make sure your critical value not positive negative, can be positive or negative, depend on are they greater or less. Okay. Okay, now your S standard error of the difference. Okay, so I have this number 32A plus 414, divide by 14 plus 11 subtract 2. Okay, and 1 divided by 14 plus 1 divided by 11. Okay, so I got 2.27. Okay, then T of 10 will be the number 51 subtract 46 divided by 2.27. I got a 2.20. So 2.20 is here. 2.20. So what does this mean?
Reject.
We reject.
H0.
So we reject H0, right? So that means we reject this one. So that means this H1 is correct, right? So that means if you don't let people sleep, they will have spend more time for reaction. Okay, so we reject, right? We reject. And when we reject, then we have to calculate effect size. Okay, so then it's 0.88. So that means this research is very strong impact. It's not only hypothesis is, we reject. Also the research itself have a strong impact. So large effect, 0.88. And then you will never have a negative number here because we have an absolute value, okay? That's it. For the ride, we already arrived New York. And now we are going to drive back to campus, right? I'm going to show you how to run SPSS.
Thank you.
So easy, right? So easy. So easy. Hopefully this can become, one day, become your favorite class.
Probably not.
Probably not. How high I need to try to buy your heart.
Okay.
I will refuse to give you candy. Okay. Okay. Let's stop here.